We are looking at modeling exponential decay here. The only prerequisite skill really is the modeling exponential growth that we did earlier in this cycle, and that's because all of the prerequisite skills that are needed here were also needed for that one. So we know exponential growth. We know the general shape. We're expecting something to start at a certain value and go up. Now, the hidden, unseen piece of this shape is the rest of our exponential heading off in our horizontally negative direction. So if exponential growth increases really fast as time goes along, then exponential decay will perform in the opposite direction, really. So exponential decay, we're going to be looking at one value that then decreases over time, all right? So we notice these two shapes are very similar. The difference is that they are just flat on opposite sides and steep on opposite sides, all right? That's the main gist of what we're focusing on. We'll notice in terms of the equation, it's built very similarly, all right? Where we have an initial value right here, where we have a decay rate, and then we have time in days, years, hours, what have you, up top in our exponent. Now, you'll notice with exponential decay, the base of our power is always going to be less than 1. When we worked with exponential growth, the base of this power was always greater than 1, even though sometimes it was only slightly above 1 before. Now it could even be slightly below 1, but it will always be less than 1. All right, so the amount of plutonium in grams is modeled by this equation right here, where T is the number of years. What is the initial amount of plutonium? Nice and easy. That's going to be our value that is multiplying by our factor. So that is 250. Oh, what's it measured in? You know what? It doesn't say. We should assume, sorry, I should have included in this question, we're working in grams here. So 250 grams of plutonium. Now, how many grams of plutonium remain after 5 years? Okay, well, if we're working after 5 years, that means our T value is equal to 5. We know how to deal with that. We're working with our amount is equal to 250. I'm hoping you're not going to hear my dog bark in a moment, but we'll see how much restraint she has. Where instead of writing a T up in this exponent, we're working with 5 because T equals 5 in this case. Nice and easy. We continue. We follow our BEDMAS. 250 times 1 over 2 to the exponent 5. I could do that right into, I could do that right into my calculator. 1 over 2, oh, that's 0.5 to the exponent 5 right here. And I can throw then my power into my calculator as well. 0.5, let's see. And I'm working with 0.03125. Now, let's ask ourselves, does that make sense? We have a really small number here. Oh, yes, absolutely. I'm expecting the number to go down from 250, so I'll need to be multiplying it by a number that is smaller than 1. In this case, I throw this into my calculator, 0.03125 times 250, and I end up with 7.81. So that is, hang on, what was the question? Ask me again, how many grams? So when we're answering this, we want to make sure we put our units in. 7.81 grams remain after 5 years, nice and easy. How many years does it take for the amount of plutonium to fall to 1.95 grams? Well, again, we're following this same equation, but this time we don't know our T value. We do know our A value. We do know we're going to be working to 1.95. We'll use the same strategy we used last time. We'll use our repeated multiplication, and we'll throw it into our calculators. 250 equals, and then we'll put in times 0.5. This is 1 year. 2, 3, 4, 5, 6, 7. 7 years is what it takes because I had to hit my equal sign 7 times. And so 1.95 equals 250 times 1 over 2 to the exponent 7. There's our key. We performed our repeated multiplication, so we know it will take 7 years. Nice work. If that's the case, folks, I want you to try out question 2 entirely on your own. You should be able to handle it right here. I encourage you pause the video once you are working your way through, once you've worked your way through, and see how you did. Good, already. So I'm hoping at this point, check your work right here, there's nothing new. I'm hoping at this point you can understand, hey, there are multiple applications to exponential decay. In this case, we're working with the depreciating value of a vehicle. Above, we worked with the decreasing amount of plutonium after it decays. You can also work with half-lives of substances within a human body, but I'm hoping at this point you feel a little bit more comfortable. Nice work.